Alright, welcome everybody. We're at school today and we are going to talk about significant figures. So, to start out with, what significant figures are used for is in experiments, you want to indicate to the person reading about your experiment how precisely you measured a number. Okay, so if you measured it down to the millimeters, you show that. If you only measured to the meters, you show that. It's an indication of to what level of precision you measured your quantity. Okay, and the acceptable amount, I guess you could say, is whatever instrument you have. Like if you have a ruler with millimeters, you measure to the millimeter and then you can estimate one digit. Okay, so a digit is significant when you're reading numbers. Okay, a digit is significant if it's 1 to 9. If anybody writes a digit down and it's anywhere between 1 to 9, that is understood to be a measured value. Okay, so now all we have to do is worry about the zeros. And the zeros are significant if they're written in between two non-zeros. And the example I have there is 230,006. Alright, it's very clear that whoever measured that number measured the 2, measured the 3, and measured the 6. Okay, and so they can't do those things without knowing that the 3 zeros in between are in fact measured zeros. Right? At the end of a number, okay, any zeros written at the end of the number, if the number contains a decimal point, those are significant numbers. So if you have the number 12,000 and there's a decimal point on the end, then that decimal point indicates that it's exactly 12,000. It is not 12,001. It is not 11,999. You have measured all three of those zeros. They are in fact significant numbers. Okay, that's when it's significant. When is a zero not significant? Well, there's two ways. Okay, first of all, any zeros written before the first non-zero is called a placeholder. Alright, you can put an infinite number of zeros in front of your first non-zero. Like, for example, the number 10 can be written 000010, and that's fine. It's still 10, but you only have two significant figures for that. Okay, the example I have here, 0.000203. Okay, the 2 is significant, the 3 is significant, and the 0 in between the 2 and the 3 are significant. But those zeros before the 2, before the first non-zero, those are not significant figures. Okay, they are not measurements, they're placeholders. Alright, the other time you could have a zero that's not significant is at the end of a whole number if there's no decimal point. So in the previous example we talked about 12,000 with a decimal point. Now this example is 12,000 with no decimal point, and that indicates that the 1 and the 2 are significant figures, but those last three zeros, those are placeholders. It might be 12,005, it might be 12,031. We don't know. They're not significant. Those zeros are only used as placeholders to show the quantity. Okay. Alright, so you know what I might do is I'll post this online and you can try the practice out for yourself, because I don't know, practice like this with a screenshot. Well, maybe we'll do a couple. This one, the 200 with the decimal, okay, anything with a decimal point, all the numbers at the end are significant, so that has 5 significant figures. This one, 0.00200 moles per liter, okay, the 2 is significant, and because there's a decimal point in this number, the zeros at the end are significant. The zeros at the beginning, maybe I should do this way. Here we go. These zeros at the beginning, okay, these are placeholders. This 2 and these 2 zeros, they're significant numbers. Okay. This next one, 12,000 centimeters, we did that one earlier. That has 2 significant figures, the 1 and the 2. And then these 3 zeros are placeholders. And then finally 12,000.00 kilometers, that has all 7 significant figures. Okay? Alright. You know what I might do is I'll post up this PowerPoint just to speed things up a little bit, and you can try the examples out on your own. Okay? Alright, exact numbers. Exact numbers are counted, exact numbers are counted quantities. They're not measured numbers. And so because they're counted, there's no chance of having a fraction. And so an exact number or a counted quantity has an infinite number of significant figures. Same thing with a unit conversion. Okay, 1,000 meters equals exactly 1 kilometer to an infinite number of significant figures. So there we go. There's the example there. 1 kilometer is 1,000 meters. My other example, 34 students, is an exact number. You can't have half a student, despite what I might joke about in class. And so therefore, because it's a counted quantity, it's 34.000 forever. Okay? Calculations. Here we go. A calculated answer cannot be have more sig figs than the tool you use to measure it. And a calculated answer must match the least precise measurement. Okay? What that means is whatever the least precise tool you use, when you take that measurement from that tool and put it in the calculation, that determines the significance. For addition and subtraction, you line up the decimal points. Okay, 25.2 plus 1.34. You type that in your calculator and you get 26.54. But the difference is you're adding 4 to some unknown quantity, right? So 4 plus an unknown does not necessarily equal 4. So we can't say that it's 4. We can't report it as significant. We report it as 26.5. Okay, we have 1, 2, 3 significant figures. This 4 is not significant because we've added it to an unknown quantity. Alright, here we go. Let's try this out. 235.05 plus 19.6 plus 2.1. Okay, there's 3 choices there. If you type it in the calculator, you're going to get 256.75. But the problem is this. You're adding 5, this 5 right here, to an unknown quantity plus another unknown quantity. And so to assume that 5 plus something equals 5 is not, it's not really, it doesn't make any sense at all. So this 5 is not significant, okay? The first significant quantities we've added together would be the 7. So the 5 rounds up and you get an answer of 256.8. Alright, this one, 58.925, subtract 18.2, you type it in the calculator and you're going to get 40.725. And the difference is this 0.025 here at the end. You're subtracting an unknown quantity from 0.025, and when you subtract an unknown quantity, you can't assume to have the same number. So I can keep the 4, the 0, and the 7. This 2 and this 5 have to go. So the 2 rounds down, and I get 40.7. Alright, multiplication and division is even easier, fortunately. For multiplication and division, what you do is you count the significant figures of each number that you're multiplying. Okay, and whatever the fewest number of significant figures are, that's what you're allowed to have in your answer. So this one, 2.19 times 4.2, if I type it in the calculator, I'm going to get 9.198. Alright, let's check it out and see. This first number, 2.19, has 3 sig figs. The second number, 4.2, has 2 sig figs. So 3 sig figs, 2 sig figs, I can only have the lesser number, so I'm only allowed 2 in my answer. So 9.198, I can keep the 9, I can keep the 1, but the rest of this 9 and this 8 have to go. So 9.198 rounds up to 9.2. Okay, keep the fewest number of sig figs in your answer. 4.311 divided by 0.07. When you type it in the calculator, you're going to get 61.58. Alright, so let's go and check this out. This first number, 4.311, has 4 sig figs. 0.07 has 1 sig fig. So we have 4 sig figs divided by 1 sig fig. You're only allowed 1 significant figure in your answer. And so of these 3 choices, my choice is this. My choice is 60 with no decimal point is the correct answer. Oh, look at this monster. 2.54 times 0.0028 times 0.0105 times 0.060. 3 choices. Okay, I type it in the calculator, I get 11.3, I believe, I hope. Okay, let's see how many I'm allowed to keep. 3 from this number, from the 2.54, 2 from this number, from the 0.0028, 3 from this number, 0.0105, and 2 from this number, 0.060. Well, 3's and 2's, I'm only allowed to keep 2, so my choice is going to be 11. Whoops, there we go. Anyhow, that is significant figures and calculations with significant figures. It was quick, so maybe you want to go through, pause it, look at some examples again. Be sure and ask some questions, okay? We have different levels of experience in the room, and that's fine, just as long as everybody can do it in the end, I'm happy, alright? So good luck with it. Make sure you come in and ask some questions if you need it, and yeah, have yourselves a good weekend. Take care.